to wrap up this section, one final approach to integrating is to use a computer algebra system. So this would be a program like Maple or Mathematica or MATLAB. All of these can handle integration in various ways. And so sometimes, if you have access to a computer, obviously you won't have access to a computer on an examination, but it's worth acknowledging that sometimes those can be good choices. So Maple, Mathematica, and MATLAB. Of course, there's other possibilities. There's Wolfram Alpha, and a free online version of Mathematica Online, stuff like that. So these can be good choices. However, it's worth acknowledging their limitations. So one example the textbook gives is, let's suppose I ask you to evaluate the antiderivative of x times x minus 3 raised to the 15th power dx. So how are we going to do this? Well, one approach would be to expand this out, and this would have, 16 terms, and do that integration. And so that certainly would work, it just wouldn't be a very fun way to do it. And so it would be far better for us to make the substitution u is equal to x minus 3, du is equal to dx. And so now we end up with x is u plus 3 times u to the 15th du. And so this is u to the 16th plus 3u to the 15th du. So u to the 17th divided by 17 plus 3/16 u to the 16 plus c, and then plug back in for x minus 3. And so this is the way that we would do things. However, if you plug into a computer algebra system, again I'm going to show off the textbook here, the computer algebra system decides to expand everything out to integrate. And so this is certainly a correct answer, but I think that this many-term monster is a less useful answer than this answer right here. So computer algebra systems can give you the right answer. In most cases they will give you the right answer. It just might not be as useful as it might otherwise be. Okay, so that's where I'm going to wrap up. There's a little discussion about numerical approximations, and we'll talk about that more in a workshop in the future. So let's wrap up this video with pre-class problems here. So which method would you use on these integrals? So there's 4 integrals here. You don't actually have to evaluate them. It's asking you to tell me which method, substitution or partial fractions or integration by parts, and for each one, tell me what's going on. So if you say you're going to do substitution, tell me this is what u is and this is what du is. If you're going to use integration by parts, tell me what u is, tell me what dv is. If it was trigonometric substitution, tell me what you're going to substitute in for x. And if it's the partial fractions, tell me what your pattern is going to be. What is going to be your a over whatever plus b over whatever? What pattern are you aiming for? Okay, that wraps up 7.6.